There's a kind of hush the universe keeps so wide, so slow, you can almost mistake it for silence. But if you listen softly enough, you might feel it breathing. Out there, beyond the scatter of stars, threads of light and shadow weave through the dark, connecting everything that has ever shone. Galaxies drift along those filaments like lanterns caught in a spider's silk, glowing gently where the strands meet. It's called the cosmic web, but names are too small for something that vast. It's more like the universe's skeleton, invisible, yet holding everything in place. For now, there's no rush to understand. Just breathe and let the image settle. Starlight caught in a net, too fine to see, yet strong enough to bind creation together. If your heart says yes, a quiet like and a soft subscribe would be lovely. Loosen your shoulders, let the night stretch around you. We'll begin together unhurried and warm. I like to imagine the beginning as a still room, dark, warm, and even as if the whole of space were taking one long, steady breath. The light then was young, the matter soft as fog, and every direction felt the same to any traveler who could have drifted there. Smoothness, almost perfect. Differences so faint they hid inside the numbers, apart in 100,000. A whisper of more here and less there, and nothing louder than that. From those hints, gravity began its patient habit. It doesn't shout, it gathers, it waits, it leans, it invites. Bit by bit, it tugged on the slightly denser places, letting them grow a touch heavier, while the emptier places relaxed into wider calm. The outlines were ghostly at first, like pencil marks under watercolor. Time sharpened them. Threads strengthened into filaments, crossings into clusters, gulfs into well-shaped hollows. Distances spread so wide that even light, faithful and swift, would need hundreds of millions of years to cross the bigger rooms between the strands. You cannot look up and see this lattice the way you see the arc of the Milky Way or the bruised glow of a city's edge. The web hides in plain sight, like bone under skin. It sets the posture of the universe, decides where galaxies gather and where they refuse to grow. But it does its work without spectacle. For most of our story as a species, we didn't know to look for it. The night offered stars and lanes of dust, a few wandering planets, the pale fan of a comet now and then. The scaffolding stayed secret. Only lately, with careful maps, wide surveys, and the quiet theater of simulation, have we learned to feel the shape of what holds everything in place. The discovery is technical in its tools and tender in its meaning. It says that emptiness is textured, that silence has a pattern, that even in the places that seem to contain almost nothing, there's a gentle architecture guiding where the little that exists will drift and rest. I think of it as a loom more than a net. Threads meet and pull, and where they cross, galaxies burn brighter and live in crowds. Between them, great veils of thinness hang at ease. The image asks for metaphors because the scales are beyond any ordinary language. But behind the poetry sits a simple grace, a smoothness with small wrinkles, a calm with a trace of restlessness, a universe that began gentle and left room for gravity to compose. The first light we can still touch with instruments carries the memory cleanly. It is not a beam from a single star, but a soft afterglow that fills all directions, the remnant of an age when the whole sky was a warm fog. Long ago, about 380,000 years after everything began, space cooled enough for the first simple atoms to settle into being. Before that, light could not travel far without being turned back. Afterward, it could move freely. That light is still moving, stretched by the growing of space until its color sits in microwaves. too long for eyes, but not for radio dishes. In the 1,960 seconds, two astronomers, Arno Penzias and Robert Wilson, stumbled on its presence while chasing a stubborn hiss in their antenna. What they had found was not a local nuisance. It was the universe's lullaby, faded but everywhere, a near-uniform glow whispering, "I was once a warm and even sea." Uniform, but not perfect. When later maps traced this afterglow with exquisite care, they found freckles, slightly warmer patches and slightly cooler patches scattered like fine grain on a photograph. Those spots are not decoration. They are a record. Warmer means denser, cooler means thinner, by the smallest margin. The pattern on that ancient sky is a baby picture in the truest sense, ordinary at a glance, astonishing in detail, containing the blueprint for what came next. A hand that knows how to read it can point to the places that would one day become great clusters of galaxies and to the wide basins that would grow into voids. To me, it feels like listening to the heartbeat of a sleeping universe and realizing the rhythm already contains the song that will be played later. Why so smooth in the first place? The name Big Bang makes many people imagine an untidy burst, debris flying, uneven and loud. The reality, after the first blink, was quieter. A brief, fierce stretch, physicists call it inflation, pulled space itself outward astonishingly fast, ironing away roughness on large scales, the way a baker's long, patient roll makes the dough lie flat. Yet nothing in nature is perfectly still at the smallest sizes. Even emptiness trembles. Quantum fields, the fabric beneath particles, hum with a built-in uncertainty. Values cannot be pinned down with absolute precision. There's always a soft blur. During inflation, that blur was magnified. The tiniest jitters swelled to cosmic size and were frozen in place as gentle ripples, a lacework of slight more and slight less, smoothed on the grand view, wrinkled in the close-up. That combination, calm overall, faintly textured underneath, gave gravity something to work with. For a long span afterward, not much happened in the way a human eye measures drama. The fog of hydrogen and helium thinned as space grew, the light cooled, and the universe drifted through a period aptly called the Dark Ages. If you could have floated there, you might have seen only a dim red hush fading toward black, felt only the hush of expansion and the soft arithmetic of time. Yet inside that quiet, gravity kept its rhythm. Where there was a whisper, more matter. It drew a breath and made it more. Where there was less, it exhaled and lightened the room further. Slowly, tiny gatherings fattened. Slowly, gaps widened. The stage remained without actors, but props were being placed. Curtains held still, but their folds remembered where they would open. The balance at play would make a tightrope walker proud. If those early ripples had been exactly zero, gravity would have had nothing to grip, no seeds, no kernels, just an endless, even mist. No galaxies, no stars, no homes for planets, no chemistry complex enough to cook life. If the ripples had been much larger, the opposite trouble would have bloomed, matter collapsing with a heavy hand, black holes crowding the stage before gentler structures had a chance to rise. That 1 in 100,000 difference earns its keep. It is modest, but it is everything. A perfect amount of imperfection, tuned enough for variety, restrained enough for order. When I look at the high-resolution maps made by missions like Planck, I see more than data. The mottled sky becomes a kind of weather report for a world that had no clouds yet. Warmer spots, slight highs. Cooler spots, slight lows. Not a forecast of rain or clear, but a forecast of where luminosity would someday gather and where darkness would linger longer. It's strange to admit that our galaxy, with its gentle spiral and its long history of star birth and star death, traces back to a speck in that map, a tiny surplus that invited more surplus, a patient snowball that would take billions of years to grow. The idea of quantum restlessness can feel cold and technical when described with equations, but the image can be softer. Picture a pond at dawn. From a distance, it looks smooth as glass. Step closer, and the surface shivers with tiny flickers, a breath of air, the brief kiss of an insect's legs, a fish turning somewhere far below. Now imagine that the pond itself begins to swell in all directions, enlarging faster than any ripple can travel, stretching those faint tremors into broad, low waves. Something like that happened to space. The little unavoidable wiggles were drawn out, laced across the whole, and kept as memory. Inflation didn't need a trigger from outside. The ripples were intrinsic. Uncertainty is part of the recipe of reality. Empty never means empty. There is always a murmur. Another picture helps, homelier but true. A smooth loaf rises in a warm kitchen. Inside, small bubbles appear at random. Leave it long enough, and they grow, pushing on the dough around them, shaping a texture that will later be fixed by heat. Slice the bread, and you see pockets where air lived, and denser strands where the grain pulled tight. On scales so large the mind blinks, the universe has a similar crumb. The vast hollows echo the loaf's bubbles. The filaments and walls resemble the springy places between. You and I live on a crumb, in one of the denser strands, orbiting a star that found its home along a thread. The tenderness of the beginning still surprises me. After the initial, incomprehensibly brief violence, the cosmos settled into patience. The early light moved outward, lengthening. The gas cooled by expanding rather than by giving up heat to anything else. Gravity gathered without hurry, because hurry wasn't needed. The web to be existed first as a possibility, lines drawn in faint ink, waiting for the page to take more color. When the first stars finally kindled, they lit at the crossings like small cities along an ancient trade road, signaling that the plan had reached a visible phase. But that comes later in the tale. The part that matters now is simpler. The skeleton was drafted when the universe was still smoothing its own breath. You might feel a quiet wonder at how much depends on how little. A fraction here, a fraction there. A timing that kept the newborn light from being trapped forever. A cooling that allowed atoms to calm their charges and hold together. A stretch that evened things out without flattening the interest from the small scales. The ingredients list is short, the patient rise is long. We sit inside the result and give it names: filament, node, void, like mapmakers labeling rivers and hills. But the riverbed came first. The water only followed its invitation. Even our tools echo the story they uncovered. To see the afterglow, we built instruments that listen rather than look, tuning them to a frequency our eyes never evolved to notice. To map the faint differences, we had to learn to trust averages and statistics, to let the truth emerge from many gentle measurements, rather than a single flashing headline. To simulate the web's growth, we fed computers with simple rules: gravity pulls, matter moves, space expands, and watched the rules, repeated over unimaginable distances and years, braid themselves into something intricate. The result on the screen looks like frost on a window at midnight, branching, merging, opening into clear panes, then feathering again. There is a playful irony in all of this. The Milky Way, with its hundreds of billions of stars, The sun with its long, steady fire, the earth with its busy weather and tides and hearts, all of it blooms from quantum fuzziness. A jitter in nothing that became something, a small seed of difference that time and gravity patiently amplified. The universe is not only stranger than it looks in a photograph, it is stranger than our ordinary categories expect. Yet it remains gentle enough to describe with breath-slow images: a pond that enlarges, a loaf that rises, a lattice that firms under skin. Even the numbers that survive the trimming are kindly. 1 in 100,000 for the early ripples, small enough to be shy, large enough to matter. 380,000 years for the moment the fog turned transparent, long by human clocks, brief by cosmic ones, the length of a cradle's lullaby stretched out. Faster than light for inflation's reach, not a contradiction, just space, making room for itself so swiftly that light, which moves through space, cannot keep up. These values are not hurdles to memorize. They are soft weights that give shape to the fabric of the story. I like to return to the very first breath, to the image of the universe exhaling gently into being. Smoothness was a gift, but not a sterile one. The tiny wrinkles were a gift too, a promise of places where gathering could begin. Gravity read those promises and began to answer them, line by almost invisible line. By the time the lights turned on, the script was legible. By the time the first clusters formed, the skeleton was strong enough to hold surprises without breaking. We live in those surprises on a world of rock and ocean, inside a galaxy that found its address along a thread drawn when everything was still almost perfectly even. When you look into the night and feel that slow, friendly hush, you are close to the beginning. The calm you sense is not a trick of distance, it's the true tempo of things at their widest. In that tempo, small asymmetries became homes. An unseen framework coaxed matter into lanterns at the crossings and left wide rooms of silence between. The web was already written in the first speckled map the universe drew of itself, a faint glow across the whole sky. We've learned to read it carefully, gently, until even the bones beneath the stars feel less like an absence and more like a quiet presence. Held softly, a little unevenness can grow into a place where light can live. Hold one simple thought close. Those tiny wrinkles were not trivial. They are why the night is dusted with lights instead of left blank, why matter learned to gather, why planets found steady paths and kept time for oceans, seasons, and breath. Had the early calm been perfect, without even a small shiver, there would be nothing to name, no stage for chemistry to practice its patient arts. The quiet restlessness of the quantum world gave the first seeds. Gravity kept the rhythm. Every speck of starlight is a gentle memorial to that necessary unevenness, a reminder that order can rise from the softest murmur of disorder, and beauty from the smallest permission slip chaos ever wrote. We can even trace the fingerprints of those first ripples in the way galaxies arrange themselves now. Astronomers make maps that do not end at the sky's surface, but sink into depth, three-dimensional surveys of millions of galaxies, each with a measured position, each a lantern marking its place. When those maps are laid out, a pattern appears that doesn't shout, but doesn't hide. Walls and strands stretching for hundreds of millions of light years, with vast rooms of almost nothing between. The scale of the spacing, the musical interval between crowded places, matches what those early quantum jitters would have planted. What began as tiny bumps in an invisible field shows up again, much later, as the guide ropes of the cosmos, the largest from the smallest, the city from the first chalk marks on the ground. There is tenderness in that origin story. Imagine the grandest arcs we know, galaxy walls that sweep across a good fraction of the observable sky, grown from causes so slight you could mistake them for numerical noise. It teaches a simple caution. Scale can mislead. The deepest foundations of a thing may be set by whispers. The bright beads we see tonight, galaxies along a strand, were strung on ripples older than any star, older than any atom cooled enough to hold together. Every light is also, quietly, a memory of the universe's earliest tremor. Those ripples were enough for gravity to find a handle, enough to turn an even fog into shape, enough to let a skeleton take form, a framework humble at first, then steadier, then strong. From quantum jitter to rivers of matter, the path was long and patient, but the line between them is unbroken. You can think of the sky as a page, and the constellations we name are only the ink. Beneath the ink is the pressed texture of the paper itself, the grain that tells your finger how the sheet was made. That grain is not made by the matter we know best. The luminous parts of the universe, the glowing gases, the star fields, the nebulae that look like veils and pillars, are garnish, lovely and thin. The main dish stays unseen. The true architecture, the frame that holds the tapestry stretched and guides where the stitches land, is shaped by something that does not shine, flicker, or glow. We call it dark matter not because it's black, but because it refuses light entirely, and without that refusal, the web would never have learned its pattern. The reasoning that led to this invisible partner is almost domestic in its simplicity. What we saw moving didn't match what we counted. In the 1,930 seconds, Fritz Zwicky studied the Coma Cluster, a sprawling congregation of galaxies. The members were rushing around their shared center so fast that, by ordinary accounting, the cluster should have flown apart like sparks from a kicked fire, yet it held together. Zwicky suggested there was missing mass dunkel. Materie, dark matter quietly increasing the cluster's gravity, giving it a deeper well to keep its stars in company. Decades later, Vera Rubin listened to the spin of spiral galaxies. By the old intuition, stars far from the center should orbit more slowly, like outer planets circling the Sunday. Instead, the rotation curves lay flat. The outskirts whirled as fast as the inner lanes, as if each galaxy lived inside a vast, unseen halo of extra mass. The numbers argued plainly for a scaffold we could not see. Other clues arrived and agreed. The smallest temperature freckles in the cosmic afterglow, the same old baby picture, encode how much matter the young universe held in various forms. Run the numbers, and ordinary matter falls short. Add dark matter, and the pattern clicks into place. Farther along in cosmic time, gravity itself draws a map for us by bending light. When background galaxies shine through clusters thick with dark matter, their images are stretched and smeared into arcs, delicate and telling. This gravitational lensing lets us trace the invisible by the way it warps the visible. The sketches built from those distortions reveal a lattice that crisscrosses space, with luminous galaxies hanging from the intersections, like dewdrops on a web at dawn. Simulations add their quiet vote. Feed a supercomputer the spare rules, space expands, gravity pulls, matter moves, and set the starting texture by the early ripples. Let it run. With dark matter included, the emerging picture looks startlingly like the one we measure. Filaments, sheets, empty rooms, crowded nodes. Remove the dark matter, and the story sags. The universe stays too smooth. The strands never tighten. The crossings never thicken into the cities of galaxies we actually see. Reality, polite but firm, keeps pointing to the same conclusion. Most of what matters, gravitationally speaking, does not shine. How much is most? A soft number will do. On the order of 85% of the matter content is dark. The atoms that build stars and bones and seas are the smaller share. The frosting we admire sits on a cake we cannot taste with eyes. That can feel unsettling at first, but there's comfort hidden in the humility. The world does not reduce itself to only what our senses catch easily. Mystery is not a flaw, it's a feature. And dark matter, for all its quiet, is generous in how it reveals itself, not through light, but through influence. It keeps galaxies from unraveling. It stiffens the spines of clusters. It holds the filaments steady across absurd distances. It is gravity's deepest ally, the unseen hand that steadies the stage while the luminous actors perform. What is it, exactly? No one knows yet, not with the simple confidence we like. Possibilities have names. Some imagine heavy, slow to interact particles that pass like ghosts through ordinary matter. Others picture feather-light axions, born in the first instance. Experiments wait in underground rooms cooled and quieted, in balloons drifting above the noisy air, in satellites watching from dark orbits. So far, the universe keeps its counsel. Strangely, that restraint makes the story richer, not poorer. The most important ingredient can be the one that refuses every spotlight, content to shape everything without ever showing its face. Picture the role this invisible mass plays in a way your hands can feel. Before a city stands, roads are drawn, intersections appear, highways arc, quiet lanes meander. Buildings and markets and homes will later choose those lines because movement chooses them first. Dark matter laid those roads. Its filaments set up the gentle slopes along which ordinary gas would flow. Where those slopes met, gas pooled and cooled, stars flickered on, galaxies collected bright beads along ancient strings. Without the scaffold, matter would drift too evenly to gather. The web would remain an idea, never a structure. Einstein taught us that gravity bends light by curving space, and this curvature becomes a soft spotlight, pointing at what we cannot otherwise notice. Look near a cluster heavy with dark matter, and distant galaxies appear as crescents, arcs, smears. The distortions are not flaws in the glass, they are signatures. By adding many such signatures together across the sky, scientists reveal a map of mass that doesn't care who shines and who doesn't. The result looks like frost again, broad panes of emptiness, separated by branching filigree, and along the filigree, the lights we can see ride like tiny lanterns. All the while, gravity itself remains the gentlest of sculptors. We like to imagine it as dramatic, because on human scales, drama helps us notice. Apples fall, planets orbit, tides move. In the wide, early universe, gravity worked without haste. It took the small, leftover ripples, the ones inflation and dark matter committed to the page, and gave them time. Where a region was denser by the smallest shade, its pull strengthened a little. That extra pull drew in more matter, which raised the pull again, which drew in more. A feedback as old as any river course. Meanwhile, the slightly thinner regions bled their grains away and became the empty halls we call voids. The collapse wasn't the same in every direction, and that made all the difference. If the pull had been perfectly uniform, everything would have gathered into isolated balls, lonely and round. But the underlying scaffolding, with its own elastic texture, made the path of least resistance uneven. Matter slipped first into wide sheets, then into narrower strands, like dough being coaxed into long ropes beneath a careful hand. At the crossings of those ropes, weight built faster. There, clusters learned their shape. Let a good simulation roll, and you'll watch this flow play out like a time-lapse of frost blooming on glass or veins spreading through a leaf. The natural world loves to reuse patterns. Gravity obliges. None of this registers on an evening, a year, or even a lifetime. A glacier's patience looks brisk by comparison, but together, the quiet pulls add up. Given hundreds of millions of years, a gossamer sheet becomes a more definite wall. Given a billion, a wall becomes a broad, star-bearing avenue. Given a few billion more, clusters rise like mountain ranges at the junctions. A web spanning billions of light years did not arrive with a flourish. It arrived by not stopping. There's a kind of democracy to the process that feels kind. Every particle, no matter how small, tugs and gets tugged. A lone proton's gravity is laughably tiny, but add the efforts of countless trillions upon trillions, and the sum becomes architecture. Gravity keeps no favorites and has no off switch. It reaches without getting tired. The elegance hides in the feedback. A slight edge becomes a stronger edge. A small lack becomes a clearer vacancy. Out of those tiny votes cast over and over, structure emerges, and with structure, places for light to linger and for life to learn the trick of staying. Walk outside on a clear night and let the sky soften your eyes. The stars you see have their own stories, but the broader pattern is more than decoration. The web they ride on is older than they are and quieter. It took the first randomness the universe allowed and turned it into roads and rooms, into a skeleton sturdy enough to carry you, me, and every leaf that ever shook against the slightest wind. That it began with wrinkles too small for any early eye to notice is not a diminishment. It is a promise kept. The largest things can grow from the most humble beginnings, if given time and a steady pull. When thoughts drift back to those first, faint fluctuations, it's fair to wonder how something so small could carry such consequence. The reply is written above us each night, traced in maps that reach beyond sight, and replayed in simulations that practice patience. It's there in dark matter holding the stage while refusing applause, in gravity's preference for the long game, in a universe that might have stayed a smooth, featureless hush, but instead chose texture, lanterns, and the possibility of asking its own questions. The web didn't arrive in bold strokes. It blossomed from restraint, tiny advantages allowed to add up, an invisible scaffolding quietly suggesting where matter should come to rest. Listen to that lesson like a lullaby. Not everything important is visible. Not everything visible is important. The unseen can be sturdy, the small decisive, the slow sure. Somewhere inside that music, stars learn to gather, galaxies learn to braid their arms, and we learn to stand under the dark and call it beautiful. Gravity does not draft blueprints or bark orders. It hears the slightest lean in space-time and leans back gently, steadily, until a hint becomes a habit, and a habit becomes a shape. From that quiet reciprocity, the web rises. The proof lies open before us in surveys that place millions of galaxies not as a scatter, but as strokes, long strings, broad walls, wide rooms of emptiness, outlined by the lines that surround them. It looks like frost feathering across a window at dawn, branching, meeting, leaving clear panes where the air stayed warm. Start a simulation from baby ripples, and one simple rule, that gravity pulls and the same lace appears. The largest structures we know, sheets of galaxies spanning hundreds of millions of light years, are not accidents or explosions caught mid-flight. They are monuments to patience. Nothing in this is exotic in its essence. The same pull that keeps your cup on the table and the moon near the Earth works here. The difference is scale and time. On a human day, gravity seems decisive. Apples fall, tides come and go. On cosmic time, it is water wearing stone, shaping canyons by insisting, not by striking. Out of chaos, filaments are teased like strands from wool, drawn taut over ages until they hold. The night sky rephrases itself under this view. Each galaxy becomes a bead, not a drifter. The bead sits on a thread stretched across space, the thread laid down long before the bead was born. The Milky Way, home to its 100 billion suns, and the slow swirl of its arms, belongs to one of those threads. We are residents of a filament, tenants of a line that predates our oceans and our continents, and even the calcium in our bones. Balance hides in the background of this story. If gravity had been shy, the early ripples would have remained as whispers forever. Interesting, perhaps, but unproductive. A quilt that never puckers, a fog that never parts. If gravity had been overbold, everything would have crashed inward too quickly, collapsing into black holes and suffocating the chance for galaxies to breathe and for chemistry to wander. The web exists because gravity is just right, firm enough to gather, gentle enough to let things unfold. It behaves less like a ruler and more like a gardener. Order is not imposed, it's cultivated. Dark matter provides the trellis, the invisible framework of ridges and crossings, and gravity coaxes the vines of ordinary matter to climb, bloom, and set seed where the sunlight of starlight can reach. Step back, and the beauty sharpens. From a nearly featureless fog, geometry arrives. From randomness, lace. The universe is not a statue but a dance that never ends. The choreography written by hands we cannot see, pulling softly across distances that mock our familiar words. Those filaments, arcing for billions of light years, are not feats of violence. They are the record of persistence. They tell in their own way that a small tug, kept up gently and without pause, can remake a whole. Where the threads meet, the story brightens. Intersections become luminous knots, nodes where gravity collects its harvest. Along the highways of the web, matter streams for ages, and where paths cross, it piles up into cities of galaxies. Imagine the long quiet of open road, miles and miles of field and sky, and then the rush of arrival, an interchange, a capital, a place whose mass you feel in your chest before you know its name. A single cluster, the neighborhood unit of a node, can cradle hundreds to thousands of galaxies. Each galaxy holds billions of stars. Many of those stars keep company with planets. The whole hub is wrapped in a deep halo of dark matter and flooded with thin gas heated so fiercely it glows in X-rays, a veil only orbiting telescopes can see. By weight, clusters are the heaviest gravitationally bound things in existence, quadrillions of suns tied into a knot by time. Think of the Coma Cluster, an old favorite first noticed more than a century ago. Thousands of galaxies gathered in a region that would be sparse by streetlight, but crowded by cosmic standards. Nothing in there simply floats. Every galaxy orbits the cluster's common center, fast enough to blur in human metaphors, yet held fast. The mood is beehive busy, buzzing, gravitationally disciplined. Often at the core sits a giant elliptical, swollen by mergers as galaxies ride the filaments into the hub and combine, again and again, over eons. The king of the hill metaphor fits only in outline. There is no crown, only the inevitability of many small joinings becoming one. The supply lines matter as much as the city. Filaments act like rivers and railways all at once, feeding the nodes with gas and galaxies. Without those lines, clusters would starve. With them, clusters keep growing. The word for this is accretion matter, sliding along the web's gradients and settling where the pull is deepest. In these busy regions, galaxies feel one another's presence often. They tug at each other's shapes, strip gas, sometimes collide and merge. Star formation can surge or quench depending on the encounter. Life out on the filaments is calmer, spaced out. Life at the hub is heady, competitive, crowded. Clusters rarely live alone. They link into larger neighborhoods, superclusters, stitched together by filaments. The Virgo supercluster is our local parish, more than 100 million light-years across, home to the Virgo cluster, and, farther out, on one of the quieter streets, our own Milky Way. Zoom out again, and you find Laniakea, a still grander basin of flow, about 500 million light-years wide, a gentle gravitational watershed, redirecting the motion of hundreds of thousands of galaxies. Even that is not the end of the sentence. It is a clause in a longer thought, part of a network so large the mind does a small double-take and then chooses to breathe rather than measure. There is an order to the growth we can feel even before we prove it. Small things first, then bigger. Tiny ripples thickened into early halos and dwarf galaxies, those combined into larger galaxies, galaxies gathered into clusters, clusters into superclusters, the superclusters traced out the great strands. A nesting that would make a set of wooden dolls smile. Gravity and dark matter provide the scaffolding at each level. The details of light and gas fill in afterward, flavored by environment. The nodes are where the hierarchy shows its fullest flourish, where the scale of matter's ambition is loud without being frantic. Our ways of knowing these places rhyme with the places themselves. Redshift surveys take the spectra of countless galaxies and turn color shifts into distances, building a 3D atlas point by point. Gravitational lensing, which uses light's gentle detour around mass, outlines the hidden halos like a charcoal rubbing, revealing the shape of the invisible hand. X-ray observations draw the heat. They show the pools of gas simmering in the clusters and the thin river steam along the filaments. Lay these maps together, and the pattern that emerges is not a random splash, but an intricate mesh of knots linked by glowing strands. Show the map beside a scan of a brain, and it is hard not to think of neurons, a comparison more poetic than literal, but evocative nonetheless. One is made of stars, the other of cells. One signals with gravity and radiation, the other with ions and electricity. Yet the resemblance in branching and nodes tugs at the same intuition. Connection matters. Structure guides flow. Hubs change the pace of life around them. The cosmos is not a mind, but it is not merely empty either. It has a knack for organization. All this gathering pushes against a slow, opposite motion. The universe expands, and that expansion accelerates under the influence of dark energy, a mystery with the habit of making emptiness push back. Clusters and nodes are anchored by gravity, but they are anchored in a current. For now, the anchors hold. The web's cities keep their residents. The highways still deliver. Far ahead, the supply lines may thin as expansion wins more ground. The image carries a soft ache, yet the present remains communal. Galaxies travel with neighbors. They form districts and boroughs and capitals. We live in a network, not on an island. What may be most striking is how much of this remains unseen in the ordinary sense. The galaxies are like streetlights. The real mass lies in the dark beneath, the unseen roads and foundations. We know them by how they shape the traffic, not by how they gleam. The lesson is steady. Influence reveals what light hides. Follow a thread away from a node and the stars thin. Keep going and the lights fall to a rare few. The web's other face appears, the voids, great bowls of underdensity that define the structure as clearly as the filaments do. Without the hollow, the filled would not read as filled. Without the quiet, the chorus would be noise. A typical void spans tens of millions of light years, the largest run to well over 100 million. Imagine a sphere so large that every star you can see with your eyes, every one would fit inside, and still, the overall impression would be sparseness. Gravity has drawn matter away along invisible slopes, leaving behind these wide rooms of almost nothing. The first deep 3D maps in the 1,970 seconds and 1,980 seconds surprised even cautious minds. Instead of a nearly even scatter with a few clumps, the data revealed chains and walls surrounding enormous, empty regions. The voids were not gaps to be filled later. They were the dominant negative space, the shape of the sculpture. Among the most famous is the Botez Void, discovered in 1981, a cavern roughly 330 million light years across. Set the Milky Way in its center and let it spin for hundreds of millions of years in any direction. You would meet only the occasional outpost, a few lonely galaxies, a flicker here, a faint pinwheel there. Not silence, but a quiet that insists. Void does not mean vacuum. Dark matter still threads through, thinner than in the web, but present. Hydrogen gas lingers, too sparse to condense easily into new stars. The average density may sit at only 1/10 of the cosmic mean. That is enough to slow complexity. Galaxies that do live there tend to be different, small, irregular, more solitary. They evolve at a gentler pace, holding their gas longer, forming stars without the jostle of frequent encounters. Some manage elegant spirals in isolation, pinwheels turning where no one watches. To study them is hard, faintness is demanding, but the reward is clarity. Environment matters. A galaxy in the hub grows by collisions and tides. A galaxy in a void grows by introspection. Voids carry another gift. They exaggerate the effect of dark energy. Because they are underdense, they expand slightly faster than the average universe, making them sensitive meters for whatever it is that pushes space to grow. By measuring how galaxies skirt the edges of voids and how the voids themselves evolve, astronomers refine their sense of dark energy's pressure. The emptiest places can speak loudest about the fate of everything. Return, for a breath, to the Gardner image. The web's threads are vines, the nodes are arbors heavy with growth, and the voids are the wind-touched clearings between. The trellis is dark matter, unseen but decisive. Gravity is the patient hand, never rushed, never tired, guiding tendrils along the lines where they catch most easily. The design is not imposed, it emerges. The beauty is not a flourish, it is a byproduct of persistence. When you lift your eyes to the night, the scene can feel like a scatter of tiny, unrelated fires. This gentler understanding lays another image over it. The lights are beads on threads. The threads meet at cities, and between those cities are open reaches where the air is thin and time moves in long strides. Our sun, our planets, our breath are nested in one of those beads, in a suburb of a larger town, in the outskirts of a larger capital, in a province of Laniakea, on a road that runs into other roads we will never travel. The cosmic web is not a metaphor for connection. It is connection, written in gravity and time. What began as ripples too small to notice has become the architecture of the visible universe. What binds it refuses the eye, yet yields to careful inference. What seems still is a work in progress. Matter keeps slipping along the filaments. The crossings keep feeding on their rivers. The basins between keep thinning into wider calm. Gathering and expansion are still negotiating, without urgency, without waste. A quiet force, a long patience, the slightest tilt in the fabric that is enough to draw lace across the dark. Sit with that, and the night deepens, not with fear, but with ease. We are not adrift in randomness. We are held by a pattern, born less of shock than of persistence. The streetlights we admire are only grace notes on a score written for instruments we rarely hear. Yet the melody carries out from the bead where we live, along the guiding threads, through the cities where galaxies hum, into the bowls of calm where almost nothing happens, and even that almost shapes the whole. The cosmic web is gravity's long whisper made visible, a skeleton soft as breath and strong enough to lift a universe. And absence redraws that whisper into shape. Without the hollows, the cosmos would feel crowded, an unbroken masonry of starlight to the horizon. Instead, it breathes, fullness beside emptiness, brightness laced with dark, structure framed by quiet. The filaments shine more surely because of the space between them, the way foam shows on a wave because the water falls away beneath. Lace needs gaps to be lace. Drift through a true void, and the feeling is unlike any open country you know. No close blaze from a billion suns, no murmur of clusters and X-rays, only a faint, even warmth from every direction. A stillness so wide it feels like a thought that never needs to finish. The nearest bustling neighbor might be hundreds of millions of light years off, too far for hurry to mean anything. Yet, even here, gravity is awake. Over great spans, matter slides outward toward the bordering threads, and the hollow deepens a slow exhale that never quite ends. Stand near the edge of such a basin, and you can sense how it shapes motion. Clusters pull inward, voids seem to push, though there's no repulsive magic at work, only a simple imbalance. A galaxy on the rim feels more tug from the rich country beyond the boundary than from the lean interior. So the flow bends away, like raindrops skirting a dome. In this quiet way, the hollows sculpt the large-scale traffic, guiding rivers of matter not by force but by absence. We call them empty, but that's a shorthand. A void is closer to a faded watercolor, wash upon wash, thinned almost to nothing than to a blank page. Some find the idea unsettling, so much room where almost nothing happens. Others feel eased by it. Space to breathe, proof that even on the grandest scales, the universe leaves room for silence and rest. The story here isn't deprivation, it's balance. The threads sing louder because the rests between notes are respected. Presence and emptiness are partners in the same choreography. Charting that choreography asks for a cartography stranger than any we use on Earth. There are no mile markers to walk up to, no milestone stones to run your fingers across. The web doesn't paint itself in obvious light. Its lines are drawn in gravity. Still, the sky can be turned into a map if you ask the right questions in the right way. First, you need depth. A 2D sky is a painting pretty, but deceptive. To understand the web, you must know how far, not just where. Distance arrives through color stretched thin by expansion, redshift. As light travels through a universe that's growing, its waves lengthen, shifting toward the red. Measure that shift carefully, and you can estimate how long the light has been on the road. The trick is like hearing the pitch of a siren soften as it recedes, except the siren is a galaxy, and the change has been written across millions or billions of years. With those distances in hand, astronomers began to build 3D atlases points, not simply sprinkled on a dome, but hung in space where they belong. What once looked like chance fires scattered on black velvet reorganized themselves into strands and sheets with broad chambers between. The cosmic web stepped out from conjecture into charted territory. Early efforts were modest by today's measure, but even those first wedges, like the CFA redshift survey in the 1,970 seconds, hinted at a texture no one had fully seen, branching like coral, airy like foam. With hollows so large, they changed one's sense of scale. Technology widened the view. The Sloan Digital Sky Survey, with its dedicated 2.5-meter telescope in New Mexico, began to sweep the sky in the late 1,990 seconds and never stopped teaching us. It could take spectra by the hundreds in a single go, turning night after night into a harvest of distances. Millions of galaxies found their places on the map. What had been a flat sprinkling became a living depth. Those maps carry more than scenery. They are instruments tuned to old music. The spacing of galaxies preserves the imprint of ancient sound waves, baryon acoustic oscillations that once rippled through the hot plasma of the early universe. These ripples left a preferred separation, a faint echo baked into the arrangement of galaxies today. Measure it, and you hold a standard ruler. With it, you can read how expansion has changed through time and glean the pressure of the dark energy that now accelerates that growth. Pretty pictures, yes. Also, precision tools, the kind that let you take the universe's pulse from your desk. Redshift isn't the only compass. Gravity bends light, and the bending can be read the way one reads wind, by watching leaves tilt. Gravitational lensing subtle stretches and smears in the shapes of distant galaxies betrays the pull of mass in the foreground, even when that mass refuses to shine. Accumulate those distortions across the sky, and you sketch the dark scaffolding itself, not just the lights hung upon it. Another method listens to the thinness between galaxies. As the light from very distant quasars passes through clouds of intergalactic hydrogen, it picks up faint absorption lines. Compare the patterns along many lines of sight, the Lyman alpha forest, and you can reconstruct the distribution of gas that traces the filaments. Piece by piece, with different tools for different layers, the invisible becomes visible enough to guide. Scale stretches language. On Earth, the largest maps circle a world 40,000 kilometers around. In the sky, a single filament can span 500 million light-years. A void can open 100 million light-years across. Yet, with patient measurement and a taste for statistics, those distances become navigable to the mind. The images drawn from such surveys cross the border between analysis and art. The web glows in renderings like living lace, coral skeletons, or the branching of neurons. The beauty is not design in the human sense. It is what gravity and time and dark matter make when left to their own slow purposes. The work continues. New instruments raise the number of measured redshifts by tens of millions, sharpening the threads and deepening the hollows on our maps. Each season of observation adds clarity to the skeleton beneath the stars. We're still early in the project of tracing the full frame. The revelations already in hand are large. We are not looking at a scatter, we're looking at a network. The gift of these maps is perspective. They shift. Where are we going? Into where do we belong? An answer with a posture rather than a destination. Our home is a bead on a thread that ties into a city that sits within a watershed of motion that nestles inside a basin still larger. We are connected outward in a way that resists loneliness. Among the early sights that fixed this truth in memory was a discovery that felt like running a hand along a mountain's flank in the dark and suddenly recognizing how far it goes. The Sloan Great Wall. 1.5 billion light-years long in the slice that revealed it. A mural of galaxies so extended that even light would spend more than 1 billion years to cross from one end to the other. The data wasn't a poem, but the reaction it inspired came close. There it was, right on the screen, proof that the universe arranges itself on scales that mock parochial awe. Clusters shine as knots. Filaments stitch between them. Voids yawn where matter had little reason to linger. A lattice, delicate and vast. This lattice is more than a catalog of wonders. It's a ledger we can audit. By measuring how tightly galaxies cluster, Sloan and its kin picked up the BAO signal, the faint preferred scale left by ancient sound. With that scale checked, we can read the expansion's history like rings in a tree and infer how dark energy has pressed outward over time. The same survey turned into a workhorse for nearly everything else. The Milky Way's structure, the zoo of galaxy types, the inventory of quasars, the demographics of small companions. Its philosophy helped as much as its hardware. Data was released to everyone with regularity. Students, amateurs, and professionals drank from the same well. Discovery sped up, not because one group worked faster, but because many minds worked it all. The maps changed how we imagine the universe, not just how we measure it. The famous wedge plots, from Sloan fans of dots splaying outward, taught a generation to see depth where there had been only a dome. Those dots resolve into threads and gaps so convincingly that planetarium shows could teach the web as both fact and feeling. The lesson was simple and gentle. The universe is not a random spray. It is a woven thing. Return for a moment to the voids, because their poetry is easy to miss in the thrill of the bright. Picture skating through the Botez Void, the great cavern discovered in 1981, 330 million light-years wide. A single patient traveler could go on for lifetimes of galaxies and meet only a few companions. Underneath that thin loneliness, there's dark matter still, and a whisper of hydrogen, too diluted to seed many new stars. The emptiness is not a failure. It's the negative space that lets the positive come forward. Galaxies born in such quiet places grow differently. With little jostle from neighbors, they keep their gas longer, form stars at a more leisurely pace, and hold their shapes unmolested. They are the slow towns of the universe. At the hubs, life is a metropolis crowded, volatile, mergers frequent, quenching and igniting in fits. Environment writes biography. Voids also serve as sensitive dials for dark energy. Because they are underdense, they expand a little faster than average, and that excess stretch magnifies whatever is driving cosmic acceleration. Trace the outlines of voids and watch how galaxies skirt their rims, and you refine your sense of the pressure that makes space grow. The least populated places end up telling us the most about the future's pace. There's an intimacy hidden in these grand scales. When you lie back and let your eyes soften, the sky can feel like a scatter of unrelated sparks. Knowing the web is there doesn't ruin the romance, it deepens it. Each spark is a bead on a thread. Each thread leads toward a hub and away across a hollow. Somewhere along one of those lines, the Milky Way holds its lane, pulling gently with its own small gravity, being pulled in turn by the greater structures that hold it. We share motion with our neighbors. We belong to a district. We have a downtown far away we'll never visit, and a countryside we cross every day without noticing. The craft of cosmic cartography turns this belonging into a picture we can keep. Redshift gives us depth. Lensing outlines the unseen bones. Quasar absorption sketches the thin connective gas. Together they layer like road, river, and elevation on an old map. The result need not be framed on a wall to serve. It can live in a quiet corner of the mind. When the night is clear, you can call it up and see the threads glowing faintly, feel the hollows opening between, and sense the slow pull of everything toward the places where everything likes to gather. The web is not an abstraction nor a human invention. It is the universe's habit of arranging itself. Written so large we had to learn new ways to look before we could read it. And still, the balance that makes it beautiful persists. Threads against hollows, presence cradled by absence. The voids are not mistakes to be filled. They are the breathing spaces that let the pattern speak. They guide as surely as the filaments guide, by saying, "Not here," so that the cosmos can say "here" more clearly in the next place over. To carry that thought is to feel less like a solitary observer and more like a participant in a pattern that stretches beyond any horizon you can name. The map does not point to a destination. It points to a belonging, a home on a thread, in a city, in a basin, in a web that drifts and holds, all at once. What touched so many hearts about those first Sloan maps wasn't only their reach or rigor, it was the way they gently placed us within the pattern. We had long recited the nesting Earth within the solar system, the sun within the Milky Way, our galaxy within a modest cluster. That cluster tucked into a wider supercluster, but seeing it drawn gave the nesting a pulse. The dots were not abstractions. Each was a city of stars, and our own city sat on one of the threads. In that glow of positions and distances, the Milky Way found its neighborhood inside Laniakea, a basin of flow hundreds of millions of light years across, where motions converge the way rain seeks a watershed. Belonging is a quiet word, but it fits. The web was not a faraway curiosity anymore. It was the architecture that holds our address. Sloan was never a last word, only a first clear voice. Newer instruments keep extending the conversation, adding more depth, more precision, more sky. The dark energy spectroscopic instrument is gathering redshifts by the tens of millions, and the Euclid mission is tracing ripples and lenses from orbit with broad, steady eyes. Each effort draws sharper threads and cleaner hollows, yet the early Sloan slices remain a landmark, the moment speculation turned into a map anyone could read. The breakthrough was not loud, but it was decisive. Theory became atlas. A hunch became a picture you could point to. There's a hush to the beauty of those visualizations. Every dot a galaxy, every galaxy a field of suns, every sun a chance for worlds, yet together the dots refuse to be merely scattered. They elongate, braid, leave rooms between threads and walls, as though the universe had been weaving all along, humbling because of the immensity, inspiring because our small hands found a way to see it. The web stays invisible to eyes, but with careful spectra and patient math, humanity traced its outline and revealed the skeleton that carries the luminous skin. Data was the vessel, but the cargo was human: curiosity, patience, and a taste for difficult questions. With well-built tools, the unseen became visible enough. The unimaginable turned chartable. The universe offered a map to its own frame. For the first time, we could hold a chart not of seas or continents, but of the bones underneath everything bright. Light, for all its speed, travels with a certain modesty. It obeys the terrain. Space and time themselves make the roads, and mass reshapes those roads. Einstein taught that gravity isn't a pulling hand but a curve in the stage, and light, though weightless, follows the curve. That is why a beam that has wandered for billions of years can arrive at our telescopes, bent, stretched, or doubled. It has skimmed past heavy country and taken the path the landscape allowed. This bending, gravitational lensing, is among relativity's loveliest promises and astronomy's most delicate tools. It lets us read the invisible scaffold by the way it sculpts the light that crosses it. The picture is simple enough to trust. Hold a magnifying glass above a page, and the letters swell and twist. Replace glass with mass galaxies, clusters, even long strands of dark matter, and the same warping happens to images far behind. Sometimes the lens is strong, and the background galaxy turns into an arc, a pair of copies, or when the symmetry is just so, a near ring of light. Sometimes the lens is gentle, and the change is too small to see in any single galaxy. But collect the shapes of millions, and you notice a shared lean, a statistical whisper that says, there is weight here. Strong lensing makes a statement in a single glance. A cluster like Abel 1689, more than 2 billion light-years away, steals the breath with its gallery of arcs, each a distant galaxy redrawn by the cluster's gravity. Read the angles, and you can weigh the unseen halo cradling the luminous members, tracing where the mass truly lies. Weak lensing speaks more softly. The Hubble Space Telescope and ground-based surveys have measured those faint alignments across wide fields, pulling a dark lattice out of what first looked like randomness. It feels like turning on a black light in a dim room and finding hidden ink glowing across the walls. The structure was always there. Now the right wavelength makes it speak. Sometimes the sky offers a demonstration that feels almost theatrical in its clarity. The Bullet Cluster is a famous case. 2 galaxy clusters that collided and passed through each other. The hot gas, the ordinary matter, smacked together and slowed, lighting up in X-rays like a bruise. But lensing maps showed the gravitating mass split from that gas, sailing ahead with the galaxies like ghosts walking through fog. The separation makes a strong, simple point. Most of the mass is dark, and it does not behave like the gas we know. No wishful thinking can move the lensing signal. Light took a curved road because the road was curved. Large, gentle lensing surveys widen the canvas. Projects like the Dark Energy Survey and Hypersuprime CAM have drawn mass maps over huge swaths of sky, revealing filaments bridging clusters just as simulations predicted. Each faint distortion adds one brushstroke until, with enough strokes, the skeleton emerges. These same measurements test our models. How quickly do structures grow? How clumpy is the mass on various scales? How has the push of dark energy changed the tempo? The answers arrive in confidence intervals and contour plots. But beneath the statistics is a lyric thought. The cosmos is using itself as the instrument space and time as lens. Gravity is composer to show us its frame. There's a second gift, hidden in lensing. It serves as a natural telescope. When alignment is kind, the foreground mass boosts the light of galaxies that would otherwise be too faint to study, letting us glimpse star fields from an era when the first structures were still young. The universe, generous without boasting, hands us its own optics. Even without lenses, the pattern of where galaxies live tells a clear story about the web's flow. They are not confetti. They line up along the filaments, cluster at the crossings, and thin out toward the voids. The reason is as physical as rain. Long before stars kindled, dark matter had already traced the hills and valleys. Hydrogen and helium, the newborn elements, slid down those gradients, cooling as they went. Streams met along the spines, more gas pooled at the nodes. Where density crept past the threshold, clouds collapsed and lit their first fires. The web was both blueprint and builder, the plan that decided where, and the conduit that delivered what was needed. Simulations make this process vivid. Seed the early ripples, include dark matter and gas, let gravity and expansion play, and the same highways appear. Gas flows along them like traffic at dawn, heading toward bright cities. Galaxies rarely wander far from the threads in these models, and the real sky agrees. The few that live deep in voids are strange and solitary, evolving at a leisurely pace with little fresh fuel. Along the filaments, by contrast, there is a steady resupply. Cold streams can funnel straight into a galaxy's disk, sometimes sparking starbursts, sometimes simply keeping the embers hot. Orientation seems to listen to the road, too. Spiral galaxies often align their spin with the direction of the thread, like wheels set true to the lane. Not all filaments are equal. Some are thick and gorged with gas, feeding rich clusters and swollen ellipticals. Others are gossamer, sustaining smaller, delicate systems that feel one drought and dim. The variety writes the diversity of forms we catalog, giants that shine with the memory of many mergers, grand design spirals that keep their grace, irregular dwarfs that jitter along, assembling themselves in fits and starts. At the intersections, the choreography is busier. Multiple streams converge, galaxies arrive in company, collisions and near misses tug on shapes and strip away gas. Clusters here do not sit, they grow, still today, the way a city grows, when all the roads lead there. This nourishment is the quiet reason star formation has not faded entirely. The universal rate has slowed since its peak about 10 billion years ago, but many galaxies still have young, blue light in their arms, because the web keeps delivering. Without those supply lines, reservoirs would have emptied long ago. The lights would have gone down everywhere, but in a few stubborn cores. Web isn't only scaffold. It is circulation, arteries, and veins, delivering what keeps the cosmos lit. Encounters along the threads do more than feed. They arrange marriages. Two galaxies, slipping along the same strand, can meet and merge, transforming disks into spheroids, flinging out streams of stars that will weather into faint shells. The timing of such meetings depends on the roads they follow, paths set in motion when the universe was whisper smooth. In this way, a galaxy's fate is partly the story of its route. Astronomers reach for earthly metaphors because the pattern invites them. Rivers and valleys, highways and hubs, deserts and fertile plains. The comparisons are imperfect, but kind. The voids are the dry basins, where little grows. The filaments are the riverlands, with steady water. A spiral, tucked into a quiet thread, can be like a town with a single road and enough rain. A cluster is a junction of trading routes, loud with traffic and change. It's an ecosystem written in gravity and time. Against all this structure, the Sloan maps return as a calm reassurance. They show the neighborhood in measured dots, but what they really offer is a feeling. We are not adrift. We are part of a mesh that has been assembling since the universe could first hold a thought. The address is long a bead on a filament, tied to a node within Laniakea's flow, but it reads naturally once you've seen it drawn. The elegance of the method that revealed it matches the elegance of the thing itself. Distances from redshift, mass from lensing, gas from quasar absorption, each layer adds a contour, and together they give the skeleton enough shape to recognize by touch. The wonder hides in the subtlety. We infer the presence of great unseen strands not by grabbing them but by watching how they bend the light of things much farther away. A candle flickers in a far window, and we deduce the wind. It takes patience to trust a clue that small, and a certain tenderness to be satisfied with an answer that refuses spectacle. Yet the answers have accumulated. Arcs around clusters, weak shears across fields, mass separated from hot gas in a cluster collision. The same pattern showing up in simulations, seeded only with small ripples and simple rules. Each clue points to the same quiet reality. The stars and galaxies are the lanterns. The design belongs to what does not shine. Hold the picture in your mind like a night map you can unfold whenever quiet returns. Threads cross and meet, nodes hum with activity. Voids give the pattern room to breathe. Our own galaxy sits along a lane that feeds into larger streets, into a downtown we will never visit, into a basin where motions converge. Light still bends as it passes the heavy parts, writing down the story of mass for any patient eye to read. Gas still rides the slopes, pooling where the pull is deepest. Galaxies still take their cues from the roads, aligning spins and trading material along the way. The web, in a word, persists slowly, gently, decisively, turning a small, early unevenness into an architecture broad enough to cradle wonder. Some nights, that sense of belonging is the sweetest part, not a triumph or a conquest, just the soft knowledge that our home has threads leading outward, and those threads are part of a pattern that reaches farther than names can hold. The maps do not promise destinations. They offer context. They show how the candle of our sun sits in a window set into a wall that is part of a larger house built on a street that bends toward a town you can only imagine. It is enough to know the house stands, and that the street is real, and that the night has structure as well as stars. The web isn't alive in the way a forest breathes or a tide turns, yet it behaves like an environment, softly setting the weather that galaxies live under, deciding where they take root, how they grow, when they rest. There's a philosophical kindness in that arrangement. The luminous cities of stars and the colder worlds that circle them aren't strewn like handfuls of sand. They're joined by invisible roads of matter, old and reliable as bedrock. Even on the widest canvases, the story is about relationships. Gravity and dark matter write the grammar. Gas and starlight speak the sentences. A single galaxy is never only itself. It drinks from the thread that carries it, answers to the neighbors up and downstream, and sends its own small influence humming along the line. When you look at a simulation or a deep survey and the web comes into view, you're not seeing decoration. Those pale strands are arteries. They ferry cold gas to where it's needed, keep clusters supplied, and make sure the universe's lamps don't go out all at once. Every bright star you spot on a clear night, some of them young and blue, some of them patient, and red likely owes its birth to a quiet delivery along a filament. A galaxy is a traveler and a garden at once, fed by the same roads that also carry its cousins. You can call the threads pathways, you can call them lifelines. Either way, they explain why the busy places are where they are, why crossings fatten into hubs, and why the cosmos chose structure instead of smoothness. The skeleton is hidden, the jewelry gleams along it. When you widen the view, the pattern complicates into continents. The universe is stitched into superclusters and walls, formations so broad that the mind has to switch gears to hold them. They run for hundreds of millions of light years, not as single, solid slabs, but as braided ridges of nodes and filaments with hollows between. To study them is to accept a new intuition about size. Our Milky Way, large enough to feel like a whole sky from the inside, becomes a syllable in a sentence written across distances a lifetime of light couldn't cross. One of these structures is home. Laniakea, immense heaven, in Hawaiian, sweeps roughly 500 million light-years across and gathers more than 100,000 galaxies into a shared flow. If light were a traveler with no need for sleep, it would still spend 500 million years getting from one edge to the other. Do that crossing nearly 10 times, and you've traced the age of Earth. And Laniakea is only one district among many. Filaments converge there, the way streams choose a valley, sliding toward a gravitational basin nicknamed the Great Attractor. We feel its pull without seeing it whole, the way you can sense the shape of a hill from the way water moves. The discovery of Laniakea came not from a photograph, but from motion. Astronomers measured how thousands of galaxies drift relative to one another and found a coordinated slide, rivers of mass converging as if the landscape were tilted. That tilt, subtle, spread over hundreds of millions of light-years, marks Laniakea's boundary. The local group where we live, the Virgo cluster nearby, many other gatherings we've long catalogued, all of them turn their heads in slow choreography toward the same basin. We are strands in a current, citizens of a province we only recently learned to name. Elsewhere, other heavyweights bend the tempo. The Shapley supercluster, about 650 million light-years away, is one of the densest concentrations of mass in the neighborhood of the observable universe. Its gravity doesn't stop at its own borders. It tugs on our part of the web too. That pull threads itself into the same pattern of motions that point us toward the Great Attractor. The effect isn't a snap of rope. It's pressure applied over ages, a nudge that becomes a pathway because time is patient. Then there are the walls, those vast palisades of light picked out in surveys like Sloan. The Sloan Great Wall, discovered in 2003, stretches something like 1.5 billion light-years across a ridge of clusters and superclusters strung together, with filaments branching outward like roots. It's one of the largest known structures, less a single object than a swath of high ground in the web's relief map. Stand outside it in your mind, and it might look like a glowing curtain hung in the dark, its weave tight where crossings crowd, looser where voids press back. Find a wall that long, and you begin to test what you mean by uniform. On the grandest scales, the universe is supposed to average out no preferred places, no special directions. And yet here is a billion light-year feature you can point to. The tension isn't an error, it's a conversation. Cosmology expects large structures to emerge when you start from small ripples and let gravity intensify them, and the models predict walls and superclusters in the numbers and sizes we see. Still, each new giant makes us check our sums and our assumptions. which is exactly what good discoveries should do. For all their pomp, these great formations are fragile when the clock is set far enough ahead. Dark energy accelerates the expansion of space, and over long spans, it will thin the roads between provinces. The rivers that now feed clusters will trickle. The shared basins will act more like separate bowls. Bound regions will keep their residence, but neighbors that are only loosely held will drift out of meaningful contact. What we map today as connected may weather into islands later. That knowledge adds a soft ache to the survey plots, like seeing a photograph of a thriving delta and knowing the upstream snows will dwindle. Names help us feel our way into this scale. Immense heaven, great wall, attractor, they're poetry by necessity. Little ladders that let us climb toward understanding. The web isn't chaos. It is fluent. It follows rules laid down when the universe was new, when the first tiny advantages were copied and amplified, when dark matter began to lay out the trellis, and gravity began its quiet training of the vines. Superclusters and walls are the skyline and the continents of that map. To know they exist is to feel both smaller and more connected. A strand is humble. A strand belongs. Addresses, even cosmic ones, start at home. The solar system circles our star at a gentle distance, and the sun circles the Milky Way's center from a seat about 27,000 light-years, out far enough from the crowded hub to be safe, close enough to see the river of starlight as a bright band. The Milky Way is a barred spiral, about 100,000 light-years across, perhaps 400 billion stars strong, and yet from the web's perspective, it's a neighborhood, not a metropolis. We share that neighborhood with more than 50 companions in the local group. 2 are peers, Andromeda and our own. Triangulum is a junior partner. The rest are small and shy, dwarfs that flicker at the edge of detectability. The local group spans roughly 10 million light-years, a tidy suburb in cosmic terms. Beyond our suburb lies a city center, the Virgo cluster, some 55 million light-years away, houses thousands of galaxies, many of them massive ellipticals, the product of countless mergers where disks were stirred into smoothness. Virgo pulls on us. It's the nearest downtown, the gravitational low place that commuters like the local group feel in their bones. For years, Virgo was the keystone of our mental map. Then the Laniakea picture arrived and widened the streets, revealing that Virgo itself is only a district in a much broader basin. The flow patterns matter as much as the addresses. Galaxies don't sit. They drift along the gentle slopes carved by mass. Track those motions and you see the border of the province. The way a watershed is defined not by fences but by which way the rivers run. Inside this continent of galaxies, our own sits on the edge of the local sheet, a relatively flat arrangement of near neighbors, Andromeda, Triangulum, a scattering of dwarfs. The sheet folds into a broader complex. The complex feeds into Laniakea's streams. If the cosmos were a city, we wouldn't be a landmark. We'd be a cozy house on a side street, tucked far from the center, with a clear sky and a quiet yard, content to watch the distant glow and keep our porch light on. From the porch, the Milky Way looks anything but modest. The disk arches overhead as a river of stars, mottled with dark lanes of dust and dotted with bright, young clumps. We orbit with a calm cadence in a spiral arm that gives us both spectacle and safety. That local comfort doesn't contradict the larger belonging, it enriches it. You can love the texture of the bark on the tree you live beneath and still savor the forest's shape. It helps to practice a zoom in your mind, Start with the solar system's clockwork, then pull back until the whole Milky Way fits into a circle. Pull back again and see the local group as a small clutch of dots. Step farther and Virgo blooms into a swarm. Keep going and Laniakea's filaments start to resolve a faint mesh stretching 500 million light-years. Finally, let the web beyond come into view. Other basins, other ridges, other currents. At each step, the thing you just left becomes a detail. The address lengthens: street, town, county, country, galaxy, group, cluster, supercluster, thread, node, province. The feeling doesn't have to be vertigo. It can be belonging. Knowing the address is oddly soothing. We're not marooned in formlessness. We sit in a layered neighborhood, our group within a cluster, our cluster within a supercluster, our supercluster woven into the web. Connection repeats like a heartbeat. The pattern reaches beyond what we've mapped. Laniakea might not be the ultimate boundary of our region. Beyond it live other superclusters and flows we haven't traced, and perhaps a wider order we don't yet suspect. Maps are drafts by design. The universe redraws itself as we learn to look. But for now, this is home, the immense heaven that holds our galaxy and many others in a shared, slow movement. There's a gentle perspective inside this address. The Milky Way isn't drifting aimlessly. It belongs to a network that guides its path, feeds its growth, and will one day set the limits of its company. When you gaze upward from a quiet place and see the brighter stars, you're standing on a small corner in a vast city. The glow in your eyes is local. The pattern it hints at is anything but. We belong to a planet, to a star, to a disk, to a group, to a cluster, to an immense heaven of galaxies woven together by gravity. The thought lands softly, threads linking threads, a web that stretches farther than words, a neighborhood that makes room for us and for silence both. The web does not think, but it connects. It does not breathe, but it nourishes. It does not speak, but it arranges conversations, gas arriving along a filament. A galaxy at a crossroads, brightening as new stars catch. A cluster humming with mergers and tides. A wall standing as a ridge where many stories meet. The same hidden skeleton that shaped the first gatherings still shapes our address. The same quiet forces still guide what becomes luminous. If you trace those forces with instruments and patience, you can draw the lines faintly and feel the comfort that comes with a map, not directions to somewhere else, but a reminder of where you already are. Home is larger than soil and sky. It isn't limited to a blue world or even to the spiral that raises a river of starlight across our nights. Home includes the hidden lattice, the long, faint filaments and bright knots that cradle galaxies, steer their motions, and, by quiet degrees, make the universe feel held. That lattice is our address written across the dark, a forwarding note for anyone wondering where we belong when the map grows enormous. It is tender to realize that our place is not a point, but a connection, a thread that meets other threads, a neighborhood with rooms and roads, a pattern that outlasts the small lights we make. That pattern has never worked alone. While gravity and dark matter have spent billions of years drawing matter together, braiding gas into strands, gathering galaxies at crossings, another influence has been loosening the weave. It does its work without color or sound. We notice it by absence, by distance gaining on us, by the stretch in the light that leaves remote galaxies redder than memory. We call it dark energy because plain words refuse to describe what it is. The name is a placeholder for a mystery with excellent manners and undeniable results. Where gravity curls its fingers, dark energy opens its palm. The story of the web's past and the outline of its fate rests on how those two gestures share the stage. A century ago, starlight offered a hint. By the 1,920 seconds, distances and spectra had sharpened enough for Edwin Hubble and others to see a trend no one had expected. The farther a galaxy lay, the faster it seemed to be receding. The universe was expanding. Many thought the growth would slow in time, like a ball thrown upward, checked by the mass of everything tugging on everything else. Some even imagined a reversal, a long breaking that would end in a fall. That picture held until two teams, decades later, used distant supernovae, the bright, reliable kind, to read the expansion's history. Those explosions behave like cosmic mileposts. Compare how bright they appear to how bright they should be, and you learn their distance. Pair that with their redshift, and you learn the pace of expansion when their light began the journey. The answer arrived with a jolt. The pace was not easing, it was quickening. Instead of a universe slowing toward stillness, we were sitting in a universe learning to hurry. Whatever drives that hurry does not clump into clouds or condense into stars. It does not thin as space grows, the way a gas does when its container expands. It seems instead to be a property of space itself, a pressure that remains steady as new space appears. Stretch a rubber sheet and the material thins. Stretch the stage of the universe and dark energy keeps its density, as if each fresh patch of room came stamped with the same subtle push. Over large distances, the push adds up. Where gravity knits, dark energy unknits, and the balance between them has changed with time. Early on, gravity had the advantage. Matter slid down dark matter slopes, pooled at nodes, lit its first fires, and sharpened the filaments as streams fed them. As ages passed and space grew, the steady pressure of dark energy began to count more. Roughly 5 billion years ago, a middle chapter by cosmic standards, the push took the lead from the pull on the largest scales. The web didn't snap. It tightened at the crossings and thinned between, as if the threads were being tugged at both ends. Bound places stayed bound. Looser ties began to stretch. The difference shows up now in how structures grow. Clusters that are truly gravitationally attached will remain families. Superclusters, those sprawling basins like Laniakea, look unified, but the outskirts already feel the strain. Over long spans, the outer threads will lengthen and pale. The centers will keep their citizens. The suburbs will drift. On small scales, gravity still rules. On the grandest scales, dark energy sets the tempo. The web lives between those two truths, woven by one, unloosed by the other. Mathematically, the simplest way to describe this push is a term that Einstein once added to his equations, the cosmological constant. He included it to keep the universe static, then set it aside when expansion was discovered, calling the inclusion a blunder. The irony is gentle and complete. Acceleration brought the term back as the cleanest explanation for dark energy's behavior. Whether the pressure is truly constant or quietly changes with time is still open. Telescopes and surveys keep chasing the answer, comparing the present-day clustering of galaxies to the faint ripples frozen into the cosmic microwave background, checking whether growth has slowed exactly as a constant push would predict. So far, the numbers lean toward steadiness. The question remains one of the deepest we can ask. An image helps. Picture a set of dots joined by elastic bands. The bands are gravity. pulling the dots together. Now slide the whole frame over a surface that is being inflated. At first, the bands hold. As the surface grows faster, the bands stretch thinner. Only the tightest knots keep their shape. The rest lengthen, the spaces widen, and neighboring groups lose touch. That is the web's future written in simple lines. Nodes enduring, filaments under tension, voids widening into broad separations. Observations trace this story in quiet statistics. Galaxy maps reveal that growth has eased compared to what it would have been without acceleration. Weak gravitational lensing, the small, coherent distortions imprinted on the shapes of distant galaxies, shows how mass clumps and how quickly those clumps deepen. The combination points to a web reaching maturity, not adolescence. No new continent-spanning walls forming, no brand new superclusters knitting themselves into the pattern. The design is established. The edges will blur as distance wins. Carry that picture forward, and the mood changes. On timescales of tens of billions of years, galaxies not bound to our local cluster will slide past a horizon beyond which their light can't reach us. This does not ask light to move slower than light. Space itself is stretching. The gap widens faster than any beam can bridge. To future observers living in our little island of mass, the sky will hold fewer and fewer external reminders. The river of the Milky Way may remain. The companion galaxies of the local cluster will still circle, collide, and merge. But the far, familiar arcs, the great walls, and remote clusters will dim, redden, and finally vanish beyond detectability. Nothing outside will announce its presence. The web will still exist in the wide sense. We will simply be unable to see that connectedness from where we are. Within the islands that persist, gravity will continue its slow craft. Galaxies will interact and fuse. Star birth will taper as the inflow of fresh gas weakens. Disks will soften into smooth ellipses, red and patient. The variety of forms we know now, grand spirals, irregular dwarfs, ringed curiosities, will fade toward a quieter sameness. Large, rounded galaxies, holding deep stores of ancient stars. Filaments will not literally snap, but they will thin into near invisibility, their role as highways of fresh material largely finished. Time keeps going. Trillions of years from now, ordinary stars will be spent. Stellar remnants, white dwarfs, neutron stars, black holes will drift through clusters like embers after a long festival. Encounters will shuffle orbits. Occasional mergers will pulse in the dark. On longer spans still, even those remnants will shed their last energies or evaporate by slow quantum means. The web's memory will live in the distribution of whatever is left, then in nothing but the quiet curvature of space. All of this leans on a guess that dark energy is steady. If it varies, the future could swing. A change that softens its pressure might let gravity's influence grow again. A change that strengthens it without limit could drive a fate more dramatic, a big rip, in which expansion overtakes even the bonds that hold galaxies. Stars and atoms together. Current evidence points toward constancy, toward a long, gentle unweaving rather than catastrophe. Certainty is not on the table. That is part of the honesty of the view. Impermanence runs through the picture like a refrain. Stars bloom and dim, galaxies meet and part, webs assemble and loosen. There's no meanness in that, only change. The web we admire is a phase, a grand one, set between the early smoothness and the distant quiet. The transience sharpens the sweetness of our moment. We live when the structure is legible, when filaments reach hundreds of millions of light years across and still scatter enough light to be seen in outline, when clusters shine at their crossings and voids deepen the contrast, when our instruments can turn faint arcs and small reshifts into maps. Telescopes act like lanterns in a cathedral big enough to feel like weather, and the stonework is still visible. The comfort is not only borrowed from the present, it rests in the pace. Dark energy does not erase, it revises. Gravity and dark matter have already written the draft, and the pages do not blow away in a gust. They will weather over eons, edges thinning, chapters separating into their own volumes. The patience of that process gives us time to look, to understand, to teach, to fold the pattern into stories that soften fear and heighten wonder. Ignorance sits beside wonder without apology. We do not know what dark energy is. We do not know why the vacuum should carry pressure, why the numbers take the values they take, whether the push will always be as gentle as it is now. A name is a handrail, not an answer. Yet the ignorance is a gift in its own way, because it keeps the door open. It makes the sky a living question. It lets each new survey, each refined lensing map, each improved supernova catalog feel like another step toward a truth that respects both measurement and mystery. The web as we see it, bright nodes, streaming threads, deep rooms between stands at the center of that truth. Gravity drew it from the first faint ripples. Dark matter gave it a skeleton. Gas rode the slopes and lit the lanterns. Dark energy now tugs at the distances and loosens the ties. The pattern is less a still photograph than a long exposure. The tracks of many small motions layered into a single image. Memory is built into it. Stars forged from streamed gas, planets from the metals those stars returned, minds from planets that learned to keep water and warmth. The web leaves fingerprints everywhere it touched. Even as its lines thin, the marks remain in what already formed. Some evenings, the idea of a future in which the greater web slips from view can feel like a smaller room. Then the thought turns, and the room feels safe. Our island will be enough for those who live in it. Their skies will still hold a river. Their instruments will still find neighbors. Their questions will rhyme with ours, even if their maps are shorter. And the luminous fact will still be true. Structure arose, light bloomed, relationships mattered. The universe once sent threads across everything. For us, now, this is the golden clarity. We can watch distant galaxies recede faster than nearer ones and know why. We can see lensing arcs around heavy clusters and read the invisible mass. We can measure how tightly clustering grows and feel the pressure that resists it. We can lay all of that on a quiet table and whisper what it means without needing to raise our voices. The web is here, and it is beautiful, and it will change. Long before we could paint those maps with telescopes, we tried sketching them with equations, teaching computers the rules of expansion, gravity, and gas, then letting the universe grow on a screen to see whether the same lace would bloom. Begin with a quiet room and a patient machine. Inside the memory of that machine, the universe is invited to grow, not as a sketch made after the fact, but as a living calculation, unfolding step by measured step. The recipe is spare. Take the early conditions whispered by the cosmic microwave background, a nearly even sea with faint statistical ripples mix in known ingredients like dark matter, ordinary matter, and a smooth, persistent push we call dark energy, and bind them with gravity's rules. Set a starting time, let the clock tick forward, and watch. At first, the change is barely there. Then the nearly uniform gathers into knots. Threads appear, thin, and tentative. Filaments thicken, clusters brighten at the crossings. Voids open, not by being carved out, but by being left behind as matter slides away. If the rules are honest and the arithmetic faithful, the digital lace that forms should echo what telescopes actually see. None of this is simple. The universe is not a tidy orrery of a few orbits. It is a conversation among billions upon billions of particles across spaces so large that words like near and far lose their grip. Each simulation particle stands in for a vast clump of matter, and every one of them feels the pull of every other. Even with supercomputers, you negotiate. You focus on gravity, which is universal, and add the rest in layers: cooling of gas, the flicker of star formation, the temper of supernovae, the feedback of black holes, all captured with subgrid rules that mimic small-scale physics inside large-scale flows. The work is craft as much as computation. You refine. You compare to maps of the sky. You adjust with care until the moving picture respects both theory and observation. A milestone came with the Millennium Simulation in 2005, a joint effort led from the Max Planck Institute for Astrophysics and its collaborators. 10 billion dark matter particles, a cube some 2 billion light-years on a side, months of computation on a machine built to do only this kind of patient thinking. When the results were rendered, the screen bloomed with a familiar strangeness: filaments threading the volume, nodes shining with cluster mass, voids yawning dark between. One could hold the camera inside that digital space and drift as if through a glass model of the cosmos, watching structure write itself in slow light. Millennium was not just an image to admire, it was a laboratory. Change the amount of dark matter, alter the pressure of dark energy, tune the rules that let galaxies light within halos. Watch how the pattern responds. The simulation became a rehearsal room where cosmological scores could be tried before the concert of data. Then came Bolshoi Great in Russian a decade's turn later, aiming smaller in box size but sharper in detail. More than 8 billion particles, high enough resolution to track the rise of the invisible cocoons called halos, where galaxies take root. Inside those halos, substructures nested like matryoshka dolls. Count them, weigh them, rank them by abundance. Compare those tallies to what surveys deduced from real skies. The mass function agreed, velocities and clustering lined up. The match gave confidence that we were not merely drawing what we wished to see. We were repeating the universe's habit with a transparent method. Gravity alone, however, leaves galaxies as dark dots, elegant but mute. So newer families of simulations, Illustris, Eagle, and their descendants added the luminous weather of gas. They allowed hydrogen to cool along filaments, condense into disks, ignite into stars, and then push back with winds from supernovae and the feasts of central black holes. In these runs, the web wasn't only a scaffold, it was circulation. Spirals settled into arms, ellipticals swelled from mergers, circumgalactic halos breathed in and out. The Milky Way and Andromeda no longer appeared as mere markers inside dark matter. They arrived as glowing, rotating cities linked by pale bridges of gas. Between the cosmic skeleton and the starlit skin, a bridge of physics took shape, spanning scales from megaparsecs to the thickness of a galactic disk. There is a particular hush that falls when one watches these universes in motion. A dim sea stippled with seeds comes alive. Threads pull taut as streams converge. Nodes brighten like towns swelling where rivers meet. Hollows widen, not by decree, but by the simple arithmetic of matter going elsewhere. It is art born of equations, beauty that does not apologize for being useful. The likeness to the real sky is good enough to make your breath slow, and good enough to teach. From the digital, observers learn where to point, what scales to measure, which patterns are normal, and which are outliers worth chasing. From the sky, theorists learn how to adjust the code so that winds aren't too violent, black holes not too greedy, disks not too fragile. The loop closes. The model and the world nod to each other. Yet humility keeps its seat at the table. Simulations can reproduce the web when they include dark matter and dark energy, but they do not reveal what those things are. The shapes they make are right. The names we give them are placeholders. The codes show how the universe behaves. They cannot tell us why the vacuum should carry pressure, why the dark matter should ignore light, why the early ripples had precisely the amplitude they did. In this way, computational cosmology is a triumph, laced with a reminder. We are sculpting an echo, and it sings, but the original voice remains off stage. The technical challenges are their own kind of poetry. Gravity is long range. It never switches off. Naively, every particle would need to speak to every other at every step. Clever algorithms cut that down, grouping distant masses, approximating their collective pull, refining to exactness only where closeness demands it. The gas, by contrast, is intimate. It shocks and cools and fragments. It hides drama on scales far smaller than any practical grid. So subgrid physics is invented with care. Rules that stand in for clouds you cannot resolve. Energy that is deposited in hints rather than in fireworks. Star formation governed by thresholds learned from nearby galaxies. As computers grow, the approximations shrink. Exascale machines will let trillions of particles dance. Magnetic fields braid and reconnect. Radiation travel with more honesty through fogs of gas. With that power comes responsibility to keep the models consonant with what the universe actually does, not just what our tastes prefer. One can feel the horizon advancing. Future runs will test alternative dark matter, warm, fuzzy, self-interacting, seeing which recipe yields halos and filaments closest to the measured kind. They will let feedback breathe with time, not as constant winds, but as gusts and lulls that leave fingerprints in metallicity and morphologies we can compare to surveys. They will simulate the sheets where filaments glide, the streams so thin they are hard to detect, the whispery gas in voids that still holds clues to the universe's expansion. The virtual will come to rival the observed, not to replace it, but to meet it with a handshake in the middle. There is another comparison that refuses to be quiet, one that lives more in imagery than in measurement, but still helps the mind find its footing. Place a high-resolution map of the cosmic web next to a scan of a neural network, and the kinship is hard to ignore. Threads and nodes, branching and hubs, sparseness between regions of traffic. The scales differ by a chasm millimeters to billions of light years, yet the geometry rhymes. It is not only poetic indulgence. Both are networks where connection matters more than any single node. In one, neurons speak by voltage and chemistry. In the other, halos and galaxies tug by gravity and trade gas along shared roads. Complexity blooms, not from mass alone, but from how that mass, or those cells, are linked. Even the numbers tease at a parallel. The brain holds on the order of tens of billions of neurons. The observable universe houses on the order of trillions of galaxies. Different by many steps, yes, but both are large enough that patterns emerge statistically. Both sit in the sweet spot where the web of connections gives rise to new behavior. Researchers have gone further, comparing clustering statistics and connectivity distributions. The two systems share mathematical habits despite their wildly different natures. The reason may be as simple as economy. Efficient networks tend to minimize cost while maximizing communication. Brains wire themselves to save energy, yet keep paths short. The universe lets matter flow along the least resisting slopes and gathers it where those slopes meet. In both cases, a web beats a grid, a mesh beats a mess. Still, caution is part of the lullaby. The cosmos is not thinking when filaments feed a cluster. A brain is not expanding space when it forms a memory. The metaphor helps because it reminds us that nature enjoys repeating motifs when similar constraints apply. Spirals in shells and storms and galaxies, branching in trees and lungs and lightning, webs in brains and cities, and the large-scale universe. We are allowed to feel wonder when the forms match. We are asked to resist claiming more than the forms permit. A softer, more personal symmetry remains. A brain, itself a network born of stardust, studies another network that once helped forge the elements that make thought possible. A neuron, contemplating a galaxy, is matter tracing a loop back to its origin. A web, reflecting on a web. Techniques cross-pollinate. Methods developed to analyze information flow in neural tissue illuminate flows in galaxy maps. Cosmological statistics for filaments and voids migrate back to neuroscience. The kinship becomes useful, and usefulness deepens the kinship. Through all of this runs a final thread, quiet but decisive. The web is not only a shape in space, it is a shape in time. When astronomers chart filaments and nodes, they are not pinning butterflies to a board. They are catching light that set out long ago. A cluster image today may be shown as it was when the first forests grew on Earth. A filament, mapped at great distance, is being seen in its youth. Even the simulations, which let the camera move freely, are keyed to this truth when we compare them to data. We take snapshots at the epochs that correspond to the ages of the light we've gathered. To look outward is to look backward. The maps are atlases of was as much as is. That realization folds everything into a single, gentle lesson. The digital universes that bloom on our screens, the faint arcs that lensing pulls from background light, the two-point correlations and higher orders that whisper how galaxies prefer to keep company, the rosy veins of hydrogen drawn from quasar spectra, the neuron-like tangle of threads in a brain and a cosmos. All of it is one fabric seen in different weaves. We simulate to rehearse, observe to witness, compare to learn and rest, sometimes just to feel the scale without flinching. The cosmic web remains the largest story we can tell with data and the softest one we can tell with awe. And every map we make is a memory book, a record of where galaxies were when their light began the journey to our night. Light moves fast, but not instantly, and across the deep it carries a calendar. A galaxy a billion light years away is a portrait from a billion years ago. Its starlight left long before forests learned the trick of wind. Reach farther 10 billion light years, and you meet a younger universe, a restless age when the first crowded neighborhoods were only beginning to assemble. To look into the cosmic web is to step into a long corridor of time where every doorway opens on a different year. Each telescope becomes an archaeologist of glow, dusting off photons that departed before our language had a word for night. The farthest background is a baby picture. The cosmic microwave background, soft, even, faintly freckled light, freed when the universe was about 380,000 years old. Nearby galaxies are today's faces. In between lies a slow flipbook, filaments tightening, clusters swelling, voids relaxing, wider hips of emptiness. When we stitch these scenes together, the result is a timeline woven in matter. Threads that cross not only space, but eras, tugging yesterday into tomorrow with a steady hand. The web in this telling is not a museum piece. It breathes. Matter still slides along its lanes. Gas still trickles toward the knots where galaxies gather. The knots still feed on what the lanes deliver. Simulations and surveys agree. Even now, stars are kindling out of fuel sent down those quiet rivers. Our own Milky Way drinks from such streams, a patient intake that keeps its nurseries lit. The web is a monument to the past and an engine for the present, both at once. Each epoch leaves a fingerprint, from the early smoothness barely anything to distinguish one patch from another. Gravity amplified the faintest wrinkles into the first threads. Within 1 billion years, galaxies began taking their places along those lines, lighting the dark with newborn blue. By 5 billion years, intersections had grown confident, voids had deepened, and the lace began to look like the pattern we recognize. Now, after roughly 13 billion years, the web is mature without being still. Filaments continue to gather, clusters continue to thicken, voids continue their slow widening. It looks serene, only because our lives are brief. Deep fields act like a family album. Far, small, irregular glows recall awkward teenage galaxies. Closer, large and settled spirals and ellipticals show the weight of time mergers remembered in shells. Star formation dialed to a steady hum or to a whisper. Clusters at middle distances reveal how nodes grow from villages to cities. Even the emptiness narrates, expanding at the edges as matter drains away toward the brighter ridges. Computers help us bind the pages, start with the near-uniform beginning, give gravity and expansion their due, and press play. Filaments emerge, halos catch gas, clusters rise where roads cross. Because the rules are honest, prediction and observation braid together. The same models can step forward too, letting us glimpse a later act, dark energy stretching distances, filaments thinning, the largest structures loosening their grip, the busy present ripening toward quieter scenes. In these movies, the web is both record and forecast, history and weather report. This double nature is what makes it linger in the mind. Ancient and newborn, the web holds the memory of quantum whispers while delivering fresh fuel to galaxies that haven't yet finished their sentences. Every star we know, including the one that warms our seas, owes its existence to the traffic on those lines. The sun is an offer answered by a filament long ago. The planets are footnotes written afterward. The thread that feeds our sky is the same that remembers the first ripples. It is tempting to treat the pattern we see as final, a sculpture hung in space-time. But rivers are always in motion. Galaxies drift along their banks. Clusters swell where channels meet. The basins between grow cleaner as water finds its way elsewhere. A tree looks still in an afternoon. Measure it leaf by leaf across years, and its height becomes a verb. The web is like that, changing on scales too broad for a lifetime to catch, alive in the wide sense of a process that doesn't tire. There's a sweetness and a sadness in the timing. We live when the light from far cities still arrives. The web stretches across our instruments with threads long enough to follow and rooms large enough to name. In ages ahead, the expansion will carry much of this glow beyond reach. The structure will remain, but its lines will slide over our horizon, until only the local cluster keeps us company. Future astronomers may look up and see a tight, modest sky, never suspecting the grandeur that once was visible. That makes today's maps feel like more than measurements. They are acts of keeping, records made while the canvas is still bright. Every filament is a sentence of time. It ties early quantum shiver to the formation of the first lights. It ties the gas now sliding toward a node to the stars that will someday kindle there. It binds the past to the future, with the present as a knot. When you look at the web, you are not only seeing where things are, you are witnessing how long light has traveled to meet you, how growth has layered itself, how change is the rule and endurance the tone. Something else waits under the awe, a philosophical tug that asks how order and chance share a roof. Step back, and the web looks choreographed threads and walls laid with a craftsman's eye. Step close, and you find the first cause is jitter, tiny, patternless variations, quantum in their uncertainty, that gave gravity something to amplify. The cosmic lace is harmony, written from noise. No single galaxy chose its spot. No committee set the grid. Like a flock wheeling without a leader, the order arose from simple rules honored by many parts. Self-organization does the heavy lifting, and the border between accident and intention goes soft. Contrast keeps the picture legible. The voids are not mistakes. They are the negative space that lets the lines speak. Without them, the pattern would blur into monotony. The music needs rests as much as notes. Lace needs holes as much as thread. Fullness and emptiness make meaning together. The web teaches that presence is only half the sentence. Perspective matters too. Beauty may be our word, our projection on a cooperative sky. Up close, life on a filament would feel like weather, local currents, neighboring galaxies, tides of gas, no symmetry in sight. Only when you place a long distance between you and the detail does the composition appear. A pointillist painting reads as dots until you step back, then it becomes a scene. In that sense, order and chaos are not a battle in the world, as much as a question of where you stand. Randomness, far from being an enemy, is often the seed. The first density ripples were stochastic, and without them nothing would have broken symmetry. Nature repeats this move. Turbulence invents eddies. Evolution, sculpted by mutations, finds structure. Noise gives rise to rhythms a heart can trust. The web is another case study, proof that disorder at one level can mature into pattern at another. Even entropy, that famous slide towards spread and sameness, makes room for local islands of grace. Stars ignite, planets congeal, minds wake. The universe as a whole tends toward mixing, yet inside that tide, the web blooms. The grace will fade, dark energy will pull, fuel will burn, but for long ages, the balance is generous. There's an irony gentle enough to keep. The largest map we can draw was born from the smallest uncertainties. Something spanning billions of light years rose from fluctuations on scales too tiny to name without mathematics. Scale is not a barrier to motif. Spiral, branch, web. These forms recur from cells to storms to galaxies because the rules that favor them are broad. The cosmic web sits in a family of shapes that thrive wherever many parts seek efficient connection. Meaning is the question that lingers when the pattern feels too elegant to ignore. Does the web hint at purpose? Or is it simply what happens when gravity, dark matter, and time share a room? The honest answer borrows from both. The web is not for us. It did not intend us. Yet it made the conditions for meaning stars to forge elements. elements to make oceans, and chemistry, and questions. Purpose, if the word is to be used without strain, is what arises locally in beings who can wonder. The web provided a stage vast enough and stable enough for wondering to learn its lines. The resemblance to other natural forms is more than a metaphor's toy. Neurons and rivers, roots and lightning, branching and netting, appear wherever flow meets constraint, wherever connection must be achieved with limited cost. The same broad rules of self-organization cross scales and materials. A network that carries nutrients through soil and a network that carries galaxies through time are not the same thing, but they rhyme. The point is not to collapse differences. It is to notice how often the world solves its problems with similar moves. Impermanence returns as a refrain. We happen to live when stars are plentiful and long threads are still visible. The web will loosen, the lights will dim, the horizon will pull away. But the memory will remain written into what has already formed into the metallicity of stars, into the fossils of clusters, into the distribution of the old red giants that will outlast most things. Order and chaos will keep their conversation, shifting into forms our words have not yet had to invent. Perhaps the gentlest conclusion is also the truest one. The web asks us not to pick sides. It is order coaxed from chance, structure balanced by emptiness, permanence leaning toward change. Up close, it is busy and irregular. From far away, it rests in a pattern that feels almost human in its symmetry. Both views are honest. The deeper honesty lies in accepting the union. What seems chaotic at arm's length can resolve into order at a remove, and what looks ordered now was once nothing but the smallest of wavers waiting for time to lend them weight. So the paradox becomes a comfort. The largest designed-looking thing we know was not designed. It is the record of many small obediences to simple laws. It is the dance between gravity and expansion, between noise and necessity, between full and hollow. Astronomers call its parts filaments, clusters, voids. Poets borrow lace, fabric, spiderweb, tapestry. Both vocabularies reach toward the same hush. The sky does not mind which language we use. It offers a shape. We do the rest. To sit with that shape on a quiet night is to let two truths meet. The universe is not tidy, and it is not senseless. It is a web of matter, of time, of relationships, draped across distances so large they teach the body to breathe more slowly. The fact that we can see it now, trace it, model it, and fold it into our stories is its own small miracle. We are part of the pattern we admire, a bead on a strand in a sheet, in a basin in a web, a mind built by stars, watching the roads that fed its making. Imagine lace lifted across a dark room. Threads breathe with a faint starry sheen. The spaces between open like quiet wells where sound never quite arrives. Nothing here is tossed at random. Lines meet lines, and at each tender crossing a knot gathers light clusters blooming like stitched rosettes. The pattern both hides and reveals, delicate and strong at once, beautiful not only for what it shows but for what it leaves untouched. The open places let your eyes rest, the strands do the speaking. Or let it be cloth, a wide, cosmic fabric. Each filament is a thread spun from something we cannot hold, hemmed with lantern cities of stars. Where threads cross, the weave tightens and holds. Where they drift apart, the weave relaxes into luminous quiet. It is not fabric for warmth or for shelter. It is fabric for becoming. Without this invisible loom, matter would have thinned and wandered, never finding the courage to kindle. Here, the warp is gravity, the weft is time, and the pattern is patience. measured in distances too large to name. A spider's work offers another doorway. Webs look frail in morning sun, thin as breath, yet they catch and keep. Scale the idea until it fills the sky. Gravity as the patient spinner, filaments as taut silk, galaxies clinging like beads of dew, each bead a world, each strand a path. From afar, the geometry feels intentional, though it rises from plain rules obeyed long enough, and like the silk in a hedgerow, these threads both hold and feed. They slow what passes, guide what wanders, deliver what's needed along lines you can't see until the light hits just right. Rivers help, too. A filament is not a line scratched on stillness. It is a channel of motion. Gas and darker matter slip along its slope, a current that remembers the way down. Junctions become lakes, reservoirs where material lingers, eddies where galaxies meet, drift, sometimes merge. The cargo isn't water. It is hydrogen's hush and helium's first breath, metals born in old fires and carried forward. The map feels alive because it circulates. The web is the body's vasculature, writ vast, tributaries, into trunks, into hearts that dim and brighten across eras. Metaphors multiply because the shape invites them. Foam, with bright walls and buoyant hollows. Coral, branching and porous. Tiny lives, building grand galleries. Branches under bark, veins leafing out from a single stem, lightning finding a path through humid air. None of these are the thing itself, and yet each is a rhyme. Nature repeats melodies when connection must be strong and cost must be small. The same tune appears wherever many parts must cooperate across distance. There is calm in these comparisons. Lace can be folded in a drawer and understood by fingertip. Fabric can be tugged along a seam. Rivers can be followed stone by stone. A spider's web can be admired in the hush just after dawn. Transferring those humble shapes to the sky softens the scale. The mind can hold what the tape measure refuses. The universe becomes less a wall and more a room. Huge, yes, but furnished with familiar lines. This instinct to see pattern is not an error. Clouds become creatures. Stars become stories. Spirals on a shell echo spirals in a galaxy. The web simply gives the instinct a bigger canvas. We reach for cloth, lace, rivers, and silk, not to deny the science, but to stand alongside it, to say, this is how it feels to look. Perhaps it's more than feeling. Flow seeks efficient routes. Connections flourish where effort is least. Empty space is not waste, but structure. The shapes we name repeat because the same quiet rules keep winning. Even the blanks carry meaning. A painter leaves white to give the color room. A composer writes silence to let the chord land. The voids are not errors, they are the pauses that let the arrangement speak. Without them, the eye would drown in uniform shine. With them, the threads gain contour, the crossings gain weight, the lanterns bloom against a gentler dark. What isn't there is part of what is. Lean closer, and a different piece appears. The web is delicate to sight but stubborn in function. It gives gently and holds firmly. It looks ephemeral and proves enduring. In the glow of a cluster you can feel bustle. In the vault of a void you can feel a breath taken and held. Between the two lies the harmony. The pattern keeps presence and absence, sharing a frame without argument. Let the imagination drift inside it. Weightlessness helps. You move without moving, carried on a current so slow it feels like rest. Filaments ladder past like dim causeways. Far off, gatherings flame softly, not in a hurry to be known. The distances stop being numbers. They become intervals, like the space between heartbeats, like the long inhale between one word and the next. A galaxy becomes a lantern you can almost cup your hands around. Another glows beyond it. Another and another. The road feels friendly, even if you never arrive. Perspective shifts as you float. Lines that seemed straight reveal gentle branching, like roots searching soil, like capillaries finding tissue. Bubbles press against bubbles in a foam of night. Knots become round dances of galaxies, slow embraces measured in orbits. The pattern isn't rigid, and it isn't random. It is grown like lace from a shuttle, like frost from a pinprick of cold, like a grove from a seed. There is humility here that doesn't diminish. Our Milky Way is just one small lamp along a single span of a single sheet in a single province of a single web. Yet the feeling that arrives isn't smallness, it's belonging. We are not perched outside the tapestry looking in. We are in the cloth, our little warmth stitched in by the same invisible hands. Memory and motion share the same rooms. These threads remember ripples from the first moments of faint suggestion, amplified by time into a path you could trace with closed eyes. At the same time, they still deliver. Gas travels, stars kindle, clusters accrete. Past and future are neighbors along every fiber. Resting here feels like pausing in a corridor where portraits and blueprints hang side by side. The scale frees you from grasping. The web does not ask to be solved in an evening. It unfolds on its own schedule, slow as rock, patient as tide. It exists whether noticed or not. It keeps its promises whether measured or missed. The imagination can relax. You do not need to hold every crossing in mind. You can let the structure hold you. The quiet is generous, and it does not mind if you close your eyes. Thoughts mirror the landscape. They arrive like small lanterns and settle along calm strands. They join and drift apart without struggle. Structure grows without forcing. Gravity, in the mind's version, is simply willingness, a readiness to let pieces find their natural neighbors. The braid of ideas thickens, then thins, then smooths into a fabric comfortable enough to sleep beneath. The gentle lesson keeps repeating. These are not highways with noise and deadlines. They are bridges with air between the slats. Knots are not cities with horns and smoke. They are gatherings, conversations held in low voices. The empty rooms are not wastelands. They are spaces saved for light to keep it from crowding itself, to keep it legible and kind. The whole arrangement is balance practiced for a very long time. Familiarity grows. The distances lose their sharpness and become texture. You stop counting and start listening. Galaxies feel less like destinations and more like neighbors whose porch lights you can see across a shared field. The web loses its strangeness and becomes a neighborhood map kept folded in a pocket you can reach without thinking. Home becomes a larger word without becoming a colder one. Stillness gathers, as if the pattern itself were closing its eyes. There is no final gate, no last turn. The strands simply continue, and the quiet deepens, and the mind learns the shape of both. The sense of being held rises and stays. What began as awe settles into rest. The story behind the sight lingers like a lullaby. From the earliest whisper of unevenness in a smooth fog, patience drew lines. Lines invited crossings. Crossings called forth lanterns. Lanterns forged elements. Elements built worlds. Worlds made minds. Minds looked back and named the lines. The circle is not a trap. It is a reassurance. What is large makes room for what is small. What is small learns to love what is large. Names help without owning. Lace, fabric, web, river, foam, coral, vein. Each one lights a corner and leaves the rest dim on purpose. None of them must be perfect to be right enough. The universe listens politely to our comparisons and keeps doing what it does, connecting, spacing, holding, releasing. It lets metaphor and measurement sit side by side like old friends on a porch swing. Knowing this doesn't pull the poetry out of the science. It puts the poetry back where it belongs, inside the fact. The web is real, mapped, modeled, measured. It is also beautiful, shaped in a way that makes breath slow and shoulders drop. The two truths share a backbone. Connection is fundamental. From atom to leaf, from river to neuron, from star to filament, the same preference for paths and gatherings, for rooms and bridges, shows through. There is comfort in that preference. What shines is tied to something. What rests has reason. Even emptiness earns its keep. The night is not a blankness we fall into. It is a structure we float within. We are not loose, we are held. Time, like distance, softens. The present sits on the past and leans into the future, and the thread beneath you carries all three without strain. Somewhere far along the line, light leaves a young galaxy and begins a journey it will finish in your pupil. Somewhere else, gas takes a turn toward a cluster and will become a star when languages we don't know yet are spoken. The corridor remains open. The lights keep arriving. Nothing here insists. That may be the sweetest part. The web does not demand belief. It offers presence. It does not crowd. It makes space. It does not conclude. It continues. You are allowed to be small and included at once. You are allowed to sleep. Let the image fade the way a fire's last coals dim. Threads keep their places in the dark. Knots hold their gentle glow. The wide rooms between are restful and deep. The sense of being in the cloth, rather than outside it, grows lighter, softer, easier to carry. Breathing and distance find the same rhythm. Shoulders loosen, eyes grow warm. Somewhere, a cluster hums under its breath. Somewhere, a void opens a little wider. Somewhere, a thin stream of gas follows its path with the patience of stone. Here, in this quiet, you are part of that patience. The lattice needs nothing from you but your ease. Let the last bright points blur. Let the fabric become background, the background become hush. What remains is the feeling of connection, unforced, unbroken, unafraid. The night is vast and kind. The threads are steady, the rooms are generous. You are already inside the pattern, and the pattern is already holding you. Rest there. Let the universe keep its gentle architecture. Let the thoughts align like small galaxies and grow still. The web continues past the edge of sight, soft as breath, sure as the dark between stars. And in that soft, sure dark, you drift a little, and then a little more, cradled by the quiet design of everything.